Now let us study about collisions. In a collision, okay, we have different things may be conserved. Let's see what are things which are conserved, which are constant. Okay, first one is the total energy is conserved. Okay, we know law of conservation energy. That energy can neither be created nor be destroyed. That is conserved here. So let's see that now. So in a collision, okay, we have two things which are conserved. We see total energy is conserved, that we know, and one more thing is know that the momentum, total momentum is conserved. Okay, the total linear momentum is conserved. The total linear momentum. Okay, and then one more thing, the total energy is also conserved. Okay, the total energy. Okay, momentum and total energy are both are conserved. That means they will not change during a collision. Okay. So momentum and energy are conserved. Okay, but the kinetic energy of the object, it need not be conserved. It can change. Okay. But you can see the total kinetic energy. Kinetic energy, it need not be conserved. Okay, it can change. Okay, need not be conserved. So kinetic energy can change, but the total energy will be constant. Kinetic energy can change. Okay, so based on this we have two kinds of collisions. Okay, let's see the types now. Let me erase the board here. I'll erase it now. So there are two types of collisions. Okay, we can take collisions generally as to be two kinds. Okay, one we say elastic collisions, other one is inelastic collisions. So collisions are of two kinds. First type we say is elastic collisions. Okay, elastic collisions. The second type is inelastic collisions. Okay, inelastic collisions. So these are the two types of collisions here, elastic and inelastic collisions. In elastic collisions, first type we say elastic collisions, the kinetic energy before collision is equal to total kinetic energy after collision. Let me write down. So total kinetic energy before collision. Okay. That means two objects hit each other. Okay. The total kinetic energy before collision is equal to the total kinetic energy after collision. For example, if you take gas molecules to hit each other, that we can take as an example of an elastic collision. Okay, so one gas molecule, say for example nitrogen molecule, goes hits another nitrogen molecule. That time we can say the energy is nearly constant. The kinetic energy is not changing. Okay. Remember, kinetic energy is due to the movement of some molecules. Next we come to inelastic collisions. Okay, remember in inelastic collisions, the kinetic energy need not be same. Okay, so it's just opposite of this. So total kinetic energy before collision, okay, it is not equal to the total kinetic energy after collision. After collision. Okay. So you can say there is a difference in energy. Let me take the chalk here. There is a difference in energy. So if we take this to this total kinetic energy, this term to the left side, let's see what happens. Okay, this is an equal to sign. I'll bring it this side. Okay, so we have here total kinetic energy, okay, before collision. Okay, the side minus this time taking left side. Okay, so total kinetic energy after collision. After collision, okay. But you saw it's not equal to, okay, not equal to, both are not equal. So there is some difference in energy. The difference in energy we write as loss in energy. Okay. There's a loss in energy. The loss in energy we write the symbol as delta Q. Okay. What happens is if two objects hit each other, okay, sound may be produced, heat may be produced. Okay. Due to that, some energy is lost. Okay. So that's the loss in energy. Okay. Now let's see one more type here. Imagine this is the first object, okay, and then it goes hits the second object here. Okay, before collision. After collision, what happens is the first object and second object stick to each other and they move together. Okay, after collision, okay, both of them stick to each other. So this we say is a perfectly inelastic collision. Okay, or a perfect inelastic collision. a perfect inelastic collision. Where can this happen? For example, we take some clay and we throw it in a vehicle, or some bubble gum goes and stick it on a vehicle. Okay, so as a vehicle or car is here. Okay. Some clay goes and sticks to it, a clay, or you can say bubble gum also. Okay. We can see sometimes bubble gum sticks to the car tire. Okay. So that time what happens is the two objects stick to each other. Okay, after collision. So we can say that is a inelastic collision. Okay, so two objects stick to each other and then they move. Okay, there's an energy loss. Okay, so it's an inelastic collision and they stick together. So we say it's a perfect inelastic collision. Okay, so these are the types of collisions. Okay, we have elastic collisions and inelastic collisions. Next, we'll see the difference between the two types of collisions. Now let's compare what's meant by elastic collision and inelastic collision, or the difference between elastic and inelastic collisions. Okay, so first one, total momentum is conserved. Okay. Here also total momentum is conserved. Okay, the momentum P is equal to mv, mass and velocity, momentum is conserved here. Next we see total kinetic energy is conserved. Kinetic energy. Okay, in elastic collision it is conserved, but in inelastic collision the total kinetic energy is not conserved. Okay, kinetic energy is not conserved there. Next we see third point, force involved are conservative forces here. Okay. During elastic collision, force involved are conservative forces, but in inelastic collision the force involved are non-conservative forces. Okay, they're not conservative. Okay, so what's meant conservative and non-conservative? Okay, so work done depends on the initial and final positions. Okay, only it does not depend on the path. That kind of force we say conservative forces. If the work done does not depend on the or for initial and final positions, but depend on the path also. Okay, that we say non-conservative forces there. The work done depends on the path here. Okay, that we say non-conservative forces. Inelastic collision is a kind of non-conservative force here. Next we see mechanical energy is not dissipated. During elastic collision, the mechanical energy doesn't change. Okay, it's not changing. Dissipate means it does not go away. Okay. But here in this case, in inelastic collision, the mechanical energy is dissipated into heat, light, sound, etc. So during collision, sound may be produced. Okay, then it's called as an inelastic collision, and the energy is lost there. Okay, it changes into another form of energy. Okay, that's why we say the kinetic energy is not conserved. Okay, because the energy changes into heat, light, or sound. Okay, these are the difference between elastic and inelastic collisions. Thank you for watching.